Okay. All right, so for today, we're going to kind of pick up where we left off last time. Right, so remember, last time we met, we were introduced to some important theorems. The polynomial remainder theorem, which, there we go, okay, which told us that if a polynomial f of x is divided by the factor x minus k, then the remainder is the value f of k, right? So in other words, this was really useful to us because this gave us another application of synthetic division, right? This told us that we could actually use synthetic division for synthetic evaluation or substitution, right? If we want to, the number that we're trying to evaluate the function at, so the k would just go out in front of the synthetic bracket, and then whatever ends up in the remainder box is f of k, right? Is the value of the function at that place, at that value of x. Okay, so that's kind of useful, not a hugely profound advantage, but it helps a little bit. More importantly, this led us down to the factor theorem, which says if k is a zero of f of x, then x minus k is a factor of f of x. And notice we use if and only if. K is a zero of f of x. If and only if x minus k is a factor of f of x. If and only if, if and only if means that this is a biconditional statement. So it's like a two-headed arrow. So the arrows go in both directions. You could start at either place. These two facts always go hand in hand. They always go together, okay? So we left off on this problem here. We were trying to solve this equation. Okay, so we have this polynomial up here, which we're going to call f of x, 25x cubed plus 25x squared minus x minus 1 equals 0. So essentially, we're just trying to find the zeros of f of x then, aren't we? Because we're setting it equal to 0 and solving. Okay, they gave us 1 0 of this polynomial function, and we were trying to find the others, right? Okay, so this is the first step. So this next homework assignment you're going to get, well, I guess this is the first one. The first one you're going to get is going to give you some problems like this, where you've got potentially, for example, a cubic polynomial, and you're trying to find the zeros. Presumably, we'd normally try to do that by factoring. Okay, this one is one that we actually could factor by grouping, but pretend we can't, because most of the ones you get, you're not going to be able to factor by grouping. So you have no recourse prior to this lesson for solving these things, okay? But in this lesson, we're going to give you some unfactorable, or I'm going to give you some unfactorable cubic or higher polynomials, but I'm going to give you a hint. I'm in the form of one of the zeros, right? And then you're going to use that to find the rest of the zeros, essentially, okay? The next lesson, we're going to go a step further. The next lesson, I'm going to add some other tools to your tool chest here, which we will start this on Friday, where I could give you a zero, and you could maybe immediately turn that into another zero, right? For example, if I gave you, and we already know one of these, if I gave you something like 2 minus 3i is a zero, then you immediately know what's another zero that goes with that. Going back to the fundamental, and we'll talk about this on Friday, but just a quick kind of look forward to Friday. Remember what our fundamental theorem of algebra said. We had the complex conjugate theorem, right? We know that complex zeros that have i's in them, imaginary zeros, always come in complex conjugate pairs. So if I'm telling you that 1 0 is 2 plus 3i, what's another zero? 2 minus 3i. Immediately you know that, right? And so you could use that extra hint to maybe give you some extra, I want to say this. It gives you some other more effective avenues to take to get these things solved. Like in that case, I could have given you a 4th degree polynomial. And because I gave you 1/2 of a complex conjugate pair and you know the other half, I'm getting 2 of the 4 zeros that I need, right? And that would have been enough, okay? So that's next lesson. That's not this one. This lesson, we're just kind of building up to that. So I gave you 1, and you'll recall on Monday what we did with this is we used the factor theorem, right? We know that if -1/5 is a 0, then we have the factor x minus -1/5, right? Here's our factor theorem. If k is a 0, then x minus k is a factor, right? So x minus -1/5 is x plus 1/5 has to be a factor of my polynomial, right? Okay, but that's not a very convenient factor because I've got a fraction in it, right? So we know that the factor x plus 1/5, we get a 0 from that by setting it equal to 0 and solving, right? And that's certainly when is x plus 1/5 equal to 0 when x equals -1/5, right? But we could write that factor in a more convenient way, right? Think about how we apply the zero product property. We know that the zeros of a product of factors are when we set the individual factors equal to 0 and solve. So we end up getting the equation. Look at this equation we get. We get the equation x plus 1/5 equals 0. I could just clear the fractions in that equation, couldn't I? And not have to deal with those fractions in my factor. If I multiply both sides by 5, look what happens. Then I get the equation 5x plus 1 equals 0. And let's use that as our factor instead, so we don't have to have a fraction in it. This really goes hand in hand with that last step in slip and slide, doesn't it? Remember what we said in slip and slide when we were factoring I mean, we didn't really do a lot of slip and slide, but when we did go through it, remember the last step was when I've got this thing factored, if there's a denominator, I just slide the 5 up in front to make it a coefficient. So that really is sort of a legal step, isn't it? Because all I am ending up doing is just multiplying, I'm distributing a 5 through, okay? Give me thumbs on that. How we doing? Okay, okay, good. All right, so we got our 5x plus 1 is the factor, the most convenient way to write the factor that goes with the 0, x equals -1/5, okay? Right, and once again, we just set that, there's our 0, we set it equal, we say x minus that equals 0, and then we just write the factor more conveniently. Okay, we got that stuff. So we know that by the zero product property, if I'm trying to find the zeros of f of x, I've got this thing written in a factored form where I know the pink factor. I don't yet know the other factor that I'm going to multiply by that, but I know that it's all got to equal 0, right? So my goal is then just going to be, if I could figure out what this other factor was, we called it q of x. If I could figure out what that is, I just need to find the zeros of that other factor because those are going to be the other 2 of the 3 total zeros, right? What's the degree of that other factor going to have to be? What do you think? Just hold up fingers. What's the degree going to be of the q of x? If the degree of f of x is 3, right? Then 5x plus 1 times what degree is going to give us, it's going to be 2, isn't it? Everybody see that? Because if I were to FOIL this out, I'm going to get a 5x times, I'm going to have to get a 5x times some x squared term there to end up getting x cubed. Does that make sense? So hey, so real quick for now, when I'm doing this stuff, I would like you guys to have like all earbuds and everything out, please. Okay, I just want to have everybody with me up here. Okay, so then our goal is we've just got to find what is q of x. How am I going to do that? I'll give you a big hint, and you probably already see the answer, but I'm going to give you a big hint. This is the really important thing, right? That equation is important. We know that our original f of x is equal to 5x, the quantity 5x plus 1 times q of x. So how would I find q of x? Divide, right? I'm just trying to isolate q of x in this equation, so I just divide each side by 5x plus 1. Everybody agree? Okay. So then we end up with q of x equals 25x cubed plus 25x squared minus x minus 1, all divided by 5x plus 1, right? And we can do that synthetically. We can do that using long division if we want to. It's fine. But we can also do that synthetically. Okay, but if we're going to do this synthetically, which is kind of our shortcut, what's wrong with the denominator? It doesn't meet the criteria for synthetic division right now. What do I have to do differently? Duluth, do you see something wrong with that denominator? Say it again. Okay, that's fine. There needs to be a variable. But if I'm dividing synthetically, the bottom has to be linear. It is. We can check that off. But what's wrong with that linear factor? The coefficient, right? Yeah, the coefficient of x has to be 1 if we're going to use synthetic division. Remember that it has to be x plus something, plus some number, or x minus some number. We can't have a 5 in front of the x to use synthetic division. Okay, so what do we do? What do we do? Dawson, you remember what we have to do there? If I need the bottom to look like just instead of 5x, it's got to be x. Not sure? Liliana, do you remember what we do there? No? Well, the bracket, you mean? We're going to do that, right? We're definitely getting there. We have to. Our goal is we want to use synthetic division, but in order to do that, I have to write the bottom as I can't have that 5 in front of the x. Anybody know remember what we have to do? We went through one like this. This is good practice. It's good practice when we were doing the synthetic division stuff in the lesson prior to this topic. The 5.6, was it 5.6 or was it, I can't remember. I lose track. But the synthetic division one, this is kind of a more advanced topic, right? And by the way, you don't have to do this. You still could just do this using long division. It's fine to do. I still think it's easier to do synthetic division here, though. I want for this advanced a class, I want you guys to know how to do this. Okay, so I can't change. I want to just rewrite this expression in a different way, but I can't change its value, right? So in the bottom, would you agree what I've got to do is just divide by 5 or multiply by 1/5, distribute a 1/5 through? But if I just distribute a 1/5 through the bottom, then that's going to change this overall expression, this quotient. So what would I also have to do? Do it to the top. Everybody see that? I've got to do the same thing to both. So essentially what I'm doing is I'm taking this quotient and I'm going to multiply by 1/5 over 1/5. 1/5 divided by 1/5 is 1, right? That's my identity number for multiplication. So I'm not changing anything. This is kind of a useful way for me to write 1, because by distributing that 1/5 through, look what happens. We end up getting on the top, if I distribute the 1/5 through, I get what? 5x cubed plus 5x squared minus 1/5 x minus 1/5. But on the bottom, that looks almost more complicated because I've got those fractions there. But look at the bottom. I'm going to get x, which is what I need, plus 1/5, which looks familiar, doesn't it? Because that's actually what we had right there. Okay? All right, so now I can do synthetic division because I've got the coefficient of x in the bottom is equal to 1. Okay, so what is the 0 of the denominator? Negative 1/5, everybody agree? Okay. And we knew that, didn't we? It's right there. Okay. So we get negative 1/5 is my 0, and here are my coefficients. 5, 5, negative 1/5, negative 1/5, and there's my remainder box. Before I do anything, I can already fill one part of this bracket in before I even start to think about this. What goes in the remainder box? 0. Absolutely. It's 0, isn't it? Good. And we know that because, look, they told us. Negative 1/5 is a 0 of the function, right? So we know right away that's 0. Okay. Now we just got to find the other stuff. Okay. Well, the other stuff is going to tell us what q of x is, isn't it? Right? This is simplifying this whole quotient so we can figure out what q of x is. So I bring down the 5. Now what? What goes here? Okay, 5 times negative 1/5 is negative 1. So then here I get, okay, so there I get, remember I'm adding, aren't I? So what goes here? What's negative 1/5 plus negative 4/5? Negative 1, good. And negative 1 times negative 1/5. And sure enough, I get 0, don't I? But look what we did. We got q of x, right? Okay, so we know q of x is given to us by this, right? So that's just telling us 5x squared plus 4x minus 1, right? Everybody see that? And we want the zeros of that, don't we? We want to find, because our goal here is we want to find the other zeros of this function. Well, those are the zeros of q of x, right? By the zero product property. We're just setting this factor q of x, which we just found, equal to 0. And solving, right? So how are we going to solve that thing? Well, we could actually use factoring, couldn't we? How do we know that? How do we know factoring is going to work? What would my magic numbers have to multiply to? Negative 5, right? They multiply to AC. Okay, so if we're finding magic numbers, they have to multiply to AC, which is negative 5, and add to B, which is 4. And we have those magic numbers. What are they? 5 and negative 1. Yeah. Okay, so then we get the magic numbers 5 and negative 1. So then we can just factor this thing by grouping. We'll just split that middle term, right? Split that middle term into 4x will split up into 5x minus x, right? Minus 1x. Everybody agree? And so we get 5x squared plus 5x minus x minus 1, right? Okay, so we can factor this by grouping. What's my GCF? Oh, come on now. What's my GCF of the first group? 5x, okay. And what's left behind? X plus 1. Okay, so we know we've got to get over here. We know we've got to get a common binomial factor. We know it's going to work. What has to go out front then? What do I have to factor out to make that happen? Ah, okay. Factor out a negative 1. And so we got our answer, don't we? Then this equals x plus 1 times 5x plus negative 1. So 5x minus 1, right? And we got our solutions then, don't we? We could, the zeros, by the zero product property, we either get x equals -1 or x equals 1/5, right? Okay, makes sense? Okay. I want to show you something though. So that all worked and that's fine. But do you see here that, I wonder what that thing is. I don't know. Do you see here that when we got these coefficients out of this synthetic process, there's no remainder. This is the constant, that's the coefficient of x, that's the coefficient of x squared. That's just a, b, and c, isn't it? Everybody see that? That's a quadratic function in standard form where that's a, that's b, that's c. So we don't even have to, we could just jump immediately into the quadratic formula, for example, if we want to, because they're giving us the values of a, b, and c. Right, so I could just do this. I could just say, well, then I know x equals -b plus or minus the square root of b squared minus 4 times 5 times -1 is plus 20, right? All divided by 10. Well, look at that. That's just -4 plus or minus the square root of 36 over 10. That gets me my answers pretty easily, doesn't it? Right? Everybody see that? Okay, thumbs. Okay, good. All right. This is pretty cool stuff, isn't it? I mean, you can tell we're taking a big step up here, right? From anything you've ever done in the past, probably, right? Okay, let's try another one. So how about this one? So this time they want us to factor f of x into linear factors, given that k is a 0 of f of x. So they're giving us 1, 0, but they're telling us the multiplicity of that 0 is 2, okay? So we can assume that this does factor then if they're telling us to factor this into all linear factors. So my job here at the end is I want to write f of x in fully factored form. Okay, good? All right, so what do I do? Help me out. Okay, good. So I'm trying to figure out a good way to represent this in the notes. How about if I do it this way? So very good. If we know k is -2, then we can turn that into a factor using the factor theorem, right? So that's giving us the factor that's telling us that x minus -2 or x plus 2 is a factor, right? Okay, what about the fact that the multiplicity is 2? What's that telling us about that factor? Adelaide, what's that tell us about that factor? If the multiplicity is 2. That means that, remember, that's a double root or a double 0. It counts twice. So what's the only way we're going to get 2 zeros out of that factor? If it's squared, exactly, right? So that's telling us that, isn't it? Right? So if we know then there's 2 of the, how many factors should we expect from this? 4, right? So we know then that this big long quartic polynomial f of x, we know that that has to equal the quantity x plus 2 squared times something else, right? How big is the something else going to be? What's going to be the degree of the other factor? You see it's going to be 2? Give me thumbs on that. Everybody see that? Because the degree of f of x is 4. If I were to expand that out, I'm going to get an x squared, right? So that's going to give me a second degree polynomial. So I'd have to multiply that by another second degree polynomial to end up getting a product that's a fourth degree polynomial, right? Okay? This is kind of like, there's a lot of detective work here. It's like doing a puzzle. So again, I'm going to call that Q for quadratic, Q of x. Good? How am I going to find Q of x? What am I going to do? Divide, right? Everybody agree? To get that Q of x by itself, I'm just going to divide by x plus 2 squared, right? Okay, so I've got a couple ways I can do that. So one way I can do that One way I can do that is I could use long division. But if I'm going to use long division, I'm going to want to probably expand out x plus 2 squared, right? So what is x plus 2 squared? And don't FOIL it. Use your expansion pattern. Use the pattern a plus b quantity squared. What is that equal to? A plus b quantity squared. You guys remember that, right? A plus b quantity squared. What is that? A squared plus 2ab plus b squared. Yeah, you got to know that one. That saves you a ton of time. So if I apply that here, then what am I going to get? What is x plus 2 quantity squared? Good. Plus 4. Good. Times q of x, right? Now we know what to divide using long division, right? So using long division, then we could set this up as, let's see, we'll go clear over here. Outside, I'm going to divide by that, right? So that's going to be in the denominator. So that goes outside. Oh, come on, don't. There we go. X squared plus 4x plus 4 is out front, right? Inside the bracket, what am I going to get? 3x cubed, blah, 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 right? That whole thing, okay? F of x. Right? And then we just got to go through that process. Okay, so we'll work our way around the room here. So, Dalub, what's the first term of the q of x, right? We're going to find this quotient. X squared goes into x to the fourth how many times? X squared, right? X squared times. And we know that because we can just do the math up here. The leading term inside divided by the leading term outside is x squared, right? And then what happens when we get a term in our polynomial above the division bracket? What do we always do? We'll distribute and subtract. Okay, good. So we'll go ahead and distribute this guy down there, and that's going to give us x to the fourth plus 4x cubed plus 4x squared. And I'm going to put the whole thing in parentheses, subtraction symbol out front, and I'll just subtract vertically. So Andrew, what's that going to give me? Well, those cancel, right? Those always have to cancel. Then what am I going to get here? What's 3x cubed minus 4x cubed? Negative x. That's like saying I've got 3x cubed minus 4x cubes is how many x cubes? Well, negative 1, right? But these are I'm just combining like terms. So the exponent stays the same, doesn't it? Right? It's like saying, 3 apples minus 4 apples gives me how many apples? Negative 1, right? Okay. Another one for you. What's negative 42x squared minus 4x squared? Once again, negative 42x squared minus 4x squared. There you go. Negative 46. There you go. Good. And then I'm subtracting 0 from these other ones, so I just bring them straight down, right? Agreed? Okay, Dawson, what's next then? After I distribute and subtract, now what? For long division. I just kind of repeat this, right? Right? Until I don't have to repeat it anymore. Okay, so now I'm starting over. I've got this Now I'm going to divide this purple polynomial into this slightly smaller polynomial. So we made some progress. So what am I going to get for my term up here now? Not sure? Adelaide, want to help him out? How do we do this? Our long division, right? This is a good review of long division. It's negative x. Yeah, how come? How come, Liliana? That's the right answer. It's negative x, but why? Yeah, okay, good, because x squared times negative x would give me negative x cubed. In other words, remember what we always do is we divide the leading term inside by the leading term outside to get that term in the answer. So in other words, negative x cubed divided by x squared. Let's get rid of, that's kind of obscuring things right there. Come on. Let's do, there we go. Let's get, oh, that's the wrong thing. There we go. That's a little better, right? So we've got negative x cubed divided by x squared is negative x. So there's my next term. And when I get a new term in the polynomial part of my answer, I distribute, right? So I distribute that negative x and I get a negative x cubed minus 4x squared minus 4x, and I'll subtract the whole thing, right? So those guys cancel. So what am I going to get here then? Negative 46x squared. Adelaide, what's negative 46x squared minus negative 4x squared? There you go. Negative 42x squared. Good. Negative 172x minus negative 4x, Liliana, is what? Negative 172x minus negative 4x. There you go, negative 168x. Good. And then I bring down the negative 168. Okay, good. All right. So now, Alan, what's next? We distributed and subtracted, and so we repeat. So what's my next term going to be? Remember, I'm always doing leading term inside divided by leading term outside. So negative, I've got my negative 42x squared divided by x squared. What's that give me? Negative 42. Good. So there's my next term. And we know that's going to be the last one because it's a constant, right? Okay. What's going to happen if I've done everything correctly here? We ought to be able to predict what's going to happen. When I distribute and subtract, what should happen? What should my remainder be? It should be 0, shouldn't it? Right? Okay, so let's just, then this is a way of checking if we did things right. So let's distribute. I get negative 42x squared. That's going to be minus 168x, right? I'm multiplying negative 42 by 4x. So the 4, I just double and redouble. That gives me negative 168x and then minus 168. And so look what happens. Presto. Everything cancels, doesn't it? Okay, as predicted, and my remainder is 0. Okay, so that told me that Q of x is equal to x squared minus x minus 42, right? Okay, there's a lot of steps in these. There's a lot of work in these problems, some of these. But it's kind of, to me, it's just cool that it's all, you know, I mean, it's hopefully growing to be comprehensible. You're starting to be able to stitch together some pretty good ideas, and this is leading down the road. I promise you, I know this seems like a lot, but you'll just continue to improve and improve and improve. When you go to college and you're taking, you know, advanced calculus or differential equations, what's really you're gonna be able to step back there and say, you're gonna have pages and pages of work, but you're just gonna be able to look at that and say, hey, man, I did that. That makes sense. And it's all leading towards a solution. And that's when it starts, man, that's really cool. And we're kind of getting there now, right? Wait till I have you guys in calculus in a couple of years. We'll have some stuff up here in calculus where we'll have several boards worth of stuff to contributing to one answer, but you'll get it. I mean, it's all part of just one continuous mathematical process. Okay, so what's another way we could do this? So we could do this instead of dividing by the product of x plus 2 squared, we could have also just used synthetic division twice, couldn't we? Okay, so I'll show you a way you can do that. This really isn't the tabular method. I'm not going to show you the tabular method today. That'll come up. I'm going to hold off on that. I'm going to hold off on that until we do. It really almost makes more sense in like 2 lessons from now. I'll show you a trick that doesn't show up in textbooks, but it's something I call tabular synthetic division that's really slick. But for today, we'll skip it. Today, we can just use repeated applications of synthetic division, right? So we've got, if I want to divide x plus 2, I have to do it twice, but I'm going to divide x plus 2 into f of x. So then out front, does everybody agree I'm going to have a negative 2? That's the 0 of x plus 2, right? And there it is right there, right? Negative 2 is a 0 with multiplicity 2. So I'll divide that in synthetically. My coefficients are 1, 3, negative 42, negative 172, negative 168. And what goes in the remainder box? Oh my gosh, we're out of time. Oh, we don't get enough time in here. Okay, we'll wrap this one up on Friday.